The expertise in maritime works stands out in the design and implementation of our own production system of reinforced concrete floating caissons used in the construction of port facilities. To carry out works of this nature, we rely on our highly qualified team of facilities experts made up of over 180 professionals who fully optimize the time spent on each project. Rover Maritime's growing policy of investment in its own resources enables us to be completely self-sufficient in the execution of works of this kind, as well as providing our team with all the best technical resources, thus guaranteeing success for all our projects. To manufacture the reinforced concrete floating caissons, we at Rover Maritime rely on our own highly advanced systems. A concrete plant which, along with its pouring arms and 3 concrete pumps, reaches a maximum production of 75 cubic meters per hour, enabling a continuous supply of concreting for the base slab and the shaft walls. A lattice crane with a load capacity of 350 tons, in addition to 2 tower cranes and several mobile cranes, and a submersible platform made up of 3 connected pontoons able to manufacture caissons of 51 by 29 meter beams. Apart from the aforementioned resources, Rover Maritime has 6,000 square meters of landstock space, as well as 3,000 additional square meters to bend, cut and pre-assemble the steel reinforcement bars, and where the reinforcement for the caisson's base slab is pre-manufactured. Now it shows the caisson construction process for the Northern Port Extension in Valencia. Caisson's dimensions were 50,609 meters length, 26.1 meter beams and 20 meters in depth. The whole process is achieved in less than 6 days, working 24/7 in 3 8-hour shifts. 6 frenetic days during which all the pieces of the puzzle have to fit perfectly together. Day 1. Construction, reinforcement and concreting of the base. The first step is to cover the whole work area in the pontoon deck with biodegradable paper to prevent the concrete from sticking to the pontoon and to help with its subsequent removal during the launch maneuver. Immediately after this, the vertical concrete formworks measuring 80 centimeters high are fitted, forming the outline of the caisson's base geometry. Using a spreader bar, the crane places the base steel reinforcement inside the formwork. This reinforcement comes from 2 previously assembled independent sections. Both are placed on the pontoon and then joined together. To concrete the base slab, the concrete is pumped from the plant using 3 pumps. The concrete is then spread using 3 pouring arms, which are able to cover the whole surface area. As it is poured in, it is vibrated. Once the base concrete strengthens, an expanding tape is placed around its edges. This is to waterproof the joints between the base and the perimeter walls. An expanding paste-like seal is also placed over the caisson slab to separate the cells into several groups depending on the results of the construction and floatability study coming from the caisson sinking maneuvering plan. Day 2. Placing of the formworks. Now the pieces, which the formwork is divided into, are moved on from the land to be placed over the base slab. The sliding formwork, which will form the walls of the caisson, are made of 6 sections weighing between 55 and 85 tons. Once assembled, the supporting bars take the strengths and are responsible for uniformly holding up the formwork when the whole structure is resting on them. To form the shaft walls, the concrete is poured into 20 cm thick layers to achieve a continuous flow. This process occurs simultaneously with the vibration operation and the placing of the steel reinforcement bars in a symmetrical cycle to avoid any decompensation in the pontoon caisson structure. To perform the activities, there are 3 work teams, each with 8 workers who pour and vibrate the concrete, as well as cleaning up any remaining concrete which may be stacked in the formwork. Days 3, 4, 5 and 6. Completion of sidewalls. The sliding system is composed of 50 hydraulic jacks and 2 pumps, which maintain the oil pressure in the circuit. These jacks move simultaneously over the supporting bars, so managing to lift the formwork. The circuit is controlled from the control center, which moves the jacks in unison and so lifts the whole structure vertically at 25 mm per stroke, with a continuous average sliding speed of 25 cm per hour. The walls are slided continuously until they reach a height of 20 meters, which signals the end of this phase. The concrete also leveled once the whole caisson reaches 1 meter below the total shaft at level 19, and the last meter till level 20 is just casted concreting the perimeter walls. The external walls form a settling basin that helps to decant the solid material during the filling process of the cells. During this construction process, it is crucial that a caisson pontoon balance is maintained with certain floatability and stability parameters to guarantee that the caisson is securely and correctly completed. To avoid any possible instability problems in the system, guarantee its cohesion and control, and to protect the concrete during the hardening period, previous studies determine the necessary ballasts to be applied. Both the ballasts of the pontoon tank and, if required, those of the caisson cells cause the caisson pontoon structure to descend. All these situations are studied in advance to ensure that the freeboard conditions and correct stability are maintained. Day 6. Removal of the supporting bars, formwork disassembly, caisson launch and transfer. After the final layers of concrete have reached the necessary levels of hardness, the whole formwork is maintained on the support bars, and the supporting bars are extracted to be cleaned and dismounted, with a view to using them again in the future. The dismantling of the 6 formwork sections takes place in the opposite order to its construction. Each section is removed by crane to land, where it is cleaned by several teams of people to avoid possible drag problems during the sliding of the shaft walls in the next caissons. The pontoon ballast controls the pressure of the caisson's removal from the platform and enable it to be launched. The caisson is then led away from the work area by tugs, leading the pontoons free to be cleaned up for the next caisson's construction. The caisson transfer, once is correctly signalled, is achieved by floating it away with a tug.